Hey, good afternoon. Good afternoon. Good afternoon. It's me again. Hey, be cool. How you doing? How are you doing? Hope that everybody is doing well on this Wednesday. Thank y'all for coming in and double tapping. I appreciate it. Hope everybody's doing good on this Wednesday afternoon. Finals should be getting up out the way. Yeah, shucks. That's what I'm talking about. That's what I like to hear. Finals out the way, knocking it out. That's what's up. So, last thing you probably want to do is be studying dosage calculations right now, right? But hey, it gets fun after a while. I can do this all day. I literally would love to do this all day. I would. Hey, hello, everybody who's coming in. How you doing? All right. I did. So I took a break. So the lives will be resuming their normal time on December the 29th. So this time I'm just coming in intermittently, giving you little tidbits here and there, meeting the new students who are going to start, reacquainting myself with the old students. Y'all are not old, but the returning students, and just giving you stuff to work on hither and thither. Okay. Hey, Elizabeth R. How are you? How are you? So, yeah, on YouTube, Barbie, which one was it? Which one caused you some confusion? All right, who wants to do some justice calculations? Do do do. It's actually right now on the YouTube. Yeah, it is. It is. So if you're not following or subscribed to my YouTube channel, it is the same name as here. Blessed Start In. Hey Kim, how you doing? So once the new year hits, the live we'll stay live on here, but until the longest that we can. But with everything going on in the news and them supposed to be going back to court and all the other stuff, I want to make sure we still have a place to study and break this stuff down. So yeah, and then, of course, you can always watch the replays that are on the channel from the sessions that we do. What'd you say? You need to practice IV and PEDS. I have an exam the first week of the second semester. That doesn't surprise me at all. Not at all, not at all. Hey, all right. So, it's a label. Okay, Barbie, let me know. I had mock med calc exam today, and I didn't do real well. Real exam is in 2 weeks. You need to practice. What was on it, Kim? Taylor, you so fast. All right, so if you don't know me, I'm Narcia Blessdarian. I help thousands of nursing students conquer and defeat dosage calculations. I use dimensional analysis. That is my main method of solving these problems because it works and it can be easy once you are taught the puzzle piece method of Nurse. Ah, let's look. It's a label. I know I hardly ever have labels, right? Okay. Hopefully, don't take it down. Hopefully. The order is for meperidine, 1.5 milligrams per kilogram by mouth every 4 hours for pain. The child. Okay, she's gonna answer it. How many milliliters will you give? Okay, so we know that the first thing that we look for is what the question is asking us. So when I say puzzles, like in real life, when you put puzzles together, they come in a box. The box has a picture on it. That's what our goal is, what we are looking for. Okay, so if we're looking for milliliters, that's what we want our equation to look like once we get done setting it up. Okay, so therefore we need to see what is the patient's weight, because this is an order right here, and it tells us that we need kilograms. So we need the patient's weight, which is obviously in pounds, so we'll have to do a conversion. And then we need the medicine. So a lot of people are confused when they see medication labels. If you're confused on this medication label, put a 1 in the chat. Put your finger in the sky. Okay. The daily dose of calculations, weight base with dimensional analysis and ratio. Barbie, I'm going to do a lot of my videos over that I have on my channel, because some of them have like ratio and proportion and dimensional analysis on there. So I'm gonna be focusing on making just the puzzle piece method, and then having the other methods available for those who need it or like it. All right, so look, a medication label is going to have the name of the medicine. So this is meperidine, right? It's pain medicine. I don't really use this a lot anymore, but hey, meperidine. So it's a pain medicine. All right. And this is what you want to look for. That is what is called your concentration. That's what you need for all of your medicine, because that's what you're trying to see how much to give the patient. So you've got an ordered amount, and we're trying to see how much of the 5 milliliters per 50 milligrams is going to equal to what's being ordered. Okay. So our puzzle pieces are going to be PPP, the patient's weight, the prescription, and the product. Okay, so anytime you have a weight-based order and you need to figure out a dosing, you need the 3Ps: patient's weight, your prescription, and your product. All right, so this right here is just how many mLs is in the whole bottle. We don't need that. Okay, we don't. It's not asking for milliliter per bottle. It's not asking for how many doses are in the bottle. So we don't need that information. Okay, the goal is what's going to help you pick out your puzzle pieces and put it in the equation, as we will see. Okay, so we have our puzzle pieces: 22 pounds. Okay, that's the patient's weight. Then it says we need 1.5 milligrams per kilogram, okay, every 4 hours. So you see that it doesn't have another dash or slash behind it, right? So that means that that is the amount for one dose. If there is no other indication of minute, hour, day, whatever, then that means that is for one dose. Okay, so this is going to be for one dose. This every 4 hours for pain is the frequency. Frequency is how often we can give the medicine. Is it asking for milliliters per day? It just said milliliters. So if it doesn't have anything else, like I said, to indicate a time that needs to be given, then it is for one dose. This is dosage calc. Okay, so now we've got our concentration. That's this right here. So 50 milligrams per 5 ml. Everything else on this label is not needed. You want to look for the concentration. You always want to look for that, unless it's asking you specific questions about the label. Okay, so now that we have our puzzle pieces, we can set up our puzzle. So if I'm looking for milliliters, I'm going to start with milliliters. So whatever the goal tells me that it wants, that's what I'm going to start with. Okay, so I'll do 5 milliliters over 50 milligrams. But you flipped it. That's not what it says. Yeah. So like I said, we're doing puzzles, right? In real life, puzzle pieces are a so if I reposition a puzzle piece, flip it, move it around, however I need to get it to fit, isn't that puzzle piece still the same puzzle piece? It's just repositioned. That's the same thing that you can do with your puzzle pieces here, okay? I need my milliliters to go on the top, and I need it to go first, because that's the only thing that we are looking for. Everything else has to cancel out, and you get things to cancel out by having the same unit of measure on the bottom, which is the denominator, and the top, which is the numerator, okay? So I've got milligrams here now. So that's the next thing that I'm looking to cancel out. You look at your units and go from puzzle piece to puzzle piece, canceling out the units so that everything cancels out except for milliliter, okay? So now I got milligrams. So I have 1.5 milligrams per kilogram. So I can cross those out. And then my patient's weight is in pounds. Am I going to convert it before I put it in the equation? No. I'm going to work smart. I'm not going to work hard, okay? Work too hard in school. All right, I'm going to rewrite this so it can be smaller because I'm running out of space already. So 1.5 mgs per kg. So now, what's our conversion? How do we convert pounds to kilograms or kilograms to pounds? What's the conversion that we use? Y'all let me know in the chat. Do you know when you post the video? Soon, Barbie, I'm working hard. I'm trying to get this book out so soon, right? Right, Elizabeth, you divide by 2.2. Toy, I see you. All right, exactly. So 1 kg is 2.2 pounds. So now my kgs are crossed out, and finally, I can put my 22 pounds, and I'm running out of space still. I squeezed it in there. And everything is now gone except for the goal. And that's how you do dimensional analysis. Okay? So we will multiply across the top, multiply across the bottom, divide the top by the bottom. I don't like writing down numbers. I don't like doing extra step. I don't like doing extra work. So guess what I'm going to do? I'm going to keep it all inside of the calculator. So I'm going to do 5 times 1.5 times 22. Yep. Divide. So I'm put all my numbers on the bottom and I'm gonna hit divide in between. 50 divided by 2.2. So we will give them 1.5 milliliters of this medicine. Okay? Anybody have any questions about this? Hey to everybody who I have not spoken to, who has come into the room. I'm Nurse C, a Blessed RN, and I'm your friendly neighborhood RN, BSN, dosage calculations, puzzle piece putting together, dosage defeating, Nurse C getting degrees, tutor. I like that. I need to say it with a British accent like Khaleesi. Anybody have any questions about this or anything about the label? Because labels don't need to be intimidating. They're just sorry, you don't encourage me. They're just what's in the bottle, which you need to know. So let's go over the part of the label. So when you see a label like this one, you'll see that it has 500 mLs inside the bottle, okay? That's the name of the medicine, okay? The NDC is the National Drug Code. If you're not in the pharmacy, it's not going to make any difference to you on the nursing floor, okay? Every code, every drug has an NDC. So that's what its code is. So then this right here, boom, boom, boom. I want you to know that is what you use. That is the concentration of the medicine, okay? And you always want to look for the concentration. And the concentration is going to be the mass per volume. So how many medication molecules are floating around in the liquid molecules, okay? Because you can't give it whole. It's in a liquid. It's a solution, all right? Thank y'all for sharing live. I appreciate it. And thank you for the likes. Got 1.7 already. Hey, turn up. Did you multiply 50 and 2.2 and divide it by the top? You can, Lizzie. So what I keep it inside the calculator. And what I do is I multiply my numbers across the top. Once I get to that end of that line at the top, I hit divide. And then all of my numbers on the bottom, I hit divide in between those. But if you were doing this to write it down on paper, you would multiply across the top, write down your number. Multiply across the bottom, write down your number. And 22 is the pounds of the patient. That's how I got 22. You're welcome. Let's see if I got another one. Okay. This looks interesting. When are my lives? Barbie, the lives are Sunday nights and Wednesday nights at 8 p.m. Central Standard Time. They are on pause for right now. So make sure you are following here or subscribed on the YouTube channel so that you can get the notifications. Right now, I'm just doing them on the fly. So whenever I get a chance to get the little inkling to do a session, I will do a quick session. But the scheduled lives will return. Working on some things, updating videos, finishing the workbook, all of that. So, and then giving y'all a break because you do need a break. Now, I know we want to study and you want to be ready and you're anxious and, you're like, oh, well, I barely got through. I need to keep my skills up. Cool. That's why we're going to just, every now and then. But back on the 29th, we'll be back in full effect, okay? Alrighty. So this is Neupogen, okay? 5 micrograms per kilogram per day for myelosuppression, secondary to chemotherapy administration. Supply is 480 micrograms per 1.6 milliliters. Excuse me. The patient weighs 100 pounds. How many milliliters per day will you give? All right, so first things first. What is the goal? I'm struggling with it completely. My teacher is really nice, but ATI in the school confused me. Come study with me, Elizabeth. And even though I'm not doing the lives, I am still doing private sessions. If you need to go over some things that are personalized and privatized to what your needs are, or you're trying to get ahead, I do have the sessions available. Got 73 on my final yesterday during this the past math. Yeah, you passed the math. What's up? That's what's up. That's what's up. Okay. So, what is the goal, y'all? After you read the question, what is the goal? What are we looking for? What do you want for me? Okay, thank you. Milliliter per day. Okay. So then what is our order? Our order is, well, this is a weight-based order. So we know we need the 3Ps, right? So our patient's weight is 100 pounds. Our prescription is 5 micrograms per kg per day. And then our medicine is 480 micrograms per 1.6 mLs, right? All right, so let's pause for a minute. Let's pause for a minute. Okay, let me write this over because I don't like how I wrote it. Isn't our goal to get milliliters per day? So milliliters on the top and day on the bottom. Don't we have a puzzle piece with day in it? So that's all you need, okay? Everything will line up, and as long as day is at the bottom, milliliters at the top, everything else crosses out, you get money, okay? So if I'm looking for milliliters, what am I going to start with? Milliliters. 1.6 ml is 480 micrograms. So I've used that puzzle piece. So now I need the puzzle piece with micrograms in it, right? So I'll do my 5 micrograms is per kg per day. Micrograms crosses out. Now we got kg and day. So we got milliliter at the top, boom, that's part of the goal. We got day at the bottom, boom, that's part of the goal. So the only thing else that needs to go are these kilograms. So, how are we going to convert the kilograms into pounds? What is our magic number? One kg is 2.2 pounds. Okay? Exactly. Once you know your metric conversions, this becomes so much easier. So if you're starting school or in school and you're still looking at your chart cheating and you don't know about memorization, get those down pat. It'll make your life easier when it comes to dosage calculations, I promise. And then, so the last thing is to put the 100 pounds, okay? I don't like these pictures because they're so big and I need to write and you barely can see it. But anyways, everything is gone now except for milliliter per day, okay? So we'll do 1.6 times 5 times 100 divided by 480 divided by 2.2 equals 0.75. 75. So if we rounded this to the nearest tenth place, what will our answer be? How am I sure to know which one is the prescription and which one is the product? So the prescription is your order, what is prescribed by the doctor. Your product is what you're given. So just like you go to the pharmacy, you pick up a product, you pick up your medicine, okay? So the prescription is what's ordered, what's prescribed. So if we rounded this to the nearest tenth, our answer would be 0.8 milliliters per day. Oh no. Alrighty. It's okay. What are the main conversions that you need to have memorized? Let's talk about it. Let's talk about it. All right. So you might have a dosage calculations test, like especially when you start out, that covers like all your metric conversions. But the ones that you will normally see when you're doing these type of problems are these. 100 over 100 was the patient's weight, Jazz. So the weight was by itself. A lot of times people want to put together things that don't belong together. Like they'll make 100 pounds is one day. 100 pounds doesn't equal a day. 100 pounds equals 100 pounds, or however many kilograms that is, right? So if it's by itself, I'm going to put it over one because it's single, it's by itself. That one does not have any significant bearing on your equation. It's more so like a placeholder to show you that, whoop, that's over there, the numerator. It's not going to go on those bottom numbers, the denominator, okay? So don't get confused when you just see me put it over one. I just want you to know that it does not go with anything. It's by itself. So what's together stays together. What's relative, what equals to each other, what is a conversion, those things go together and they're on a puzzle piece. Everything that is single stays by itself and it's on its own puzzle piece. Okay? Hey, Fruit Snap Mama, how you doing? All right, so what are we talking about? Okay, so we're talking about the conversions that you would need for school. You're at work trying to watch and see these patients. Toy, you can watch the replay. Don't fret. I always try to put something up so that y'all can go back and reference it again. Slow it down, speed it up, however, right? So, all right, let's talk about this because all of these can be so simple. It can all be so simple, okay? So, this is your base unit, okay? So, it could be a gram, it could be a unit, it could be a meter, it could be a liter, okay? All of these are different because they have a prefix. So that's milli, that's micro, that's kilo, right? So if I have one base unit and I break it down, that's going to be 1,000, okay? So 1 gram is broken down into 1,000 pieces. If I pick up one of these little pieces and break it down further, that's going to be 1,000 of those smallest pieces. So micro is the smallest, okay? And I use a cookie analogy. So if y'all like talking about cookies, let's focus on some cookies for a second, okay? So if you have one cookie, that's your gram, right? So if you have a cookie and you break it into 1,000 crumbs, that is a milligram. So that's a milligram crumb. If you pick up that crumb and crumble it even more, just pulverize it, right? And it's really, really small, dust, almost dust pieces. Those are your micrograms. So 1,000 little small dust pieces come together to make a crumb. 1,000 crumbs come together to make one cookie. And then the kilogram, that's the big kahuna, right? So if you go to Costco's or you go to Sam's and you buy a big container, so one big container has 1,000 cookies in it. So think 1,000, 1,000, 1,000, 1,000. Yeah, it don't have to be hard. You just have to remember which one is the biggest one. So the gram, that's the base unit. So that's your one cookie, right? Then your kilogram, that's your big container, kilo container. That's how I kind of remember stuff in nursing school. I relate it to something, right? And then you got your 1 gram cookie. You break it down 1,000 times into crumbs. So then you take a crumb and you smash it down into even further residue. So 1,000, 1,000, 1,000. And then you kind of can see the difference that it makes for like when you're giving medicine and you give a milligram instead of a microgram. You gave them 1,000 times more than what was ordered. Woo! So that's why it kind of puts it into perspective. Okay, so you'll need those. Okay, so and then of course if you change it to liter, you got 1 liter is 1,000 milliliters. Okay. Then if you had units, 1 unit is 1,000 milliunits. Okay. Excuse me. Can we go over rounding? Yeah, we can go over rounding real quick. All right. So then the other thing that you need to know in dosage calculations, your conversion. So we're just going over must knows, okay? And I have these on my website. And there's a post on there too that's kind of pinned on TikTok. And you can screenshot it, you can download from the website, whatever, do whatever you want with it. All right, so we know that 1 kg is 2.2 pounds. And then you also need to know that 1 pound is 16 ounces. You'll need that for, stop trying to solve my problems. All right, so you'll need that for your pediatric questions, okay? So you'll need those. Then you also need, and these are the biggest ones that are kind of a pain to kind of learn, but you'll need them because you'll see them, all right? So these are like your household. So that's your teaspoon, your tablespoon, your ounces, okay? So 1 teaspoon, 1 tablespoon, 1 ounce, 5 ml, 15 ml, 30 ml. Do you see a pattern here? So 5 times 3 is 15. 15 times 2 is 30. 5, 15, 30. The smallest one is the teaspoon. You put a teaspoon on top of the table in the ounce house. I don't know. Okay? So then you'll also need the continuation of that for the cups, right? So 1 cup is 8 ounces, okay? And then we have 1 pint is 2 cups. 2 pints is 1 quart. And then 4 quarts is a gallon. Okay? And that's pretty much, oh, one more thing. You'll need for your BSA problems, for like your height, so length and measurements and such, you need that 1 foot, which is US measure, is 12 inches. And then 1 inch is 2.54 centimeters. And that's what you need. That's what I'm looking for. Trying to look over here on YouTube as well, because I am on YouTube right now as well. Okay, so somebody was asking, can we go over rounding? How many people have a problem with rounding? We'll go over that real quick. Then I gotta go get my toddler. Maybe two more problems. Then I go get my toddler. Yes, me. All right. So let me break it down. I also have a video on this. So if it goes over your head and you need to kind of reference this, I have a dosage calculations basics video, like a playlist. So yeah, we have to do heparin. I can do a heparin question for you. Sure could. Let's talk about this rounding real quick, and then we'll do a heparin question. You're amazing. I just passed my T's, so I'm trying to prepare before school. Oh, thank you. You're amazing, and congratulations. All right. So, well, rounding, right? Rounding. So, let's pick a number. I'm going to pick. All right. So, when you round, it's going to tell you where they want you to round it to. Okay? This is the whole number. So, whole number. This is the tenths place. This is the hundredths place. Okay? You want to start at the place that they tell you to round to. Okay? So let's say they told us to round to the nearest whole number. Identify the whole number. So the whole number is all of your numbers that is to the left of the decimal. Okay? So this is the whole number. So I'm going to start right there. You want to go one decimal place to the right. So boom. That's one decimal place to the right. If this number is 4 or below, it's a no-go. So that means that that number will not change of this place that you're trying to round to. It would stay the same. And then every number that's behind where it told you to round is gone. Okay? So since this is 5 or more, you're going to raise the score. So it's 8. It's more than 5, right? So we're going to increase that number that we underline by 1. So our rounding to the whole number would be 7. Okay? Boom. So let's say we were rounding the same number to the tenths place. Okay? So we're going to start at the place that it tells us to round to, which is the tenths place, right? Or they might say 1 decimal place. So you just went 1 decimal place past the decimal. So this number is where you start. You go to its neighbor, okay? Because that number is 5 or more, we increase the score, right? So the whole number is staying the same because we have no bearing on the whole number. We're trying to figure out what to put in that tenths place, that 1 decimal place. So we increase it by 1. So it's going from 8 to 9, and then the rest of it disappears. Okay? Does that make sense? Excuse me. All right, let's do one more, and then I'm gonna do heparin. So let's round. Okay, let's round this number to the nearest whole number. What would our answer be if we round this to the nearest whole number? Maybe go over BSA. I can do a BSA. So a heparin and a BSA before I leave today. What would this number be if we rounded it to the whole number? So this is your whole number. I'm going to go 1 decimal place to the right because that number right there is 4 or below. It's a no-go. So that disappears and it's just going to stay the same. So that would be my answer if I rounded it to the whole number. So if I had the same number and I rounded it to 1 decimal place, I rounded to 1 decimal place. This is the decimal place that I want to start at. I go to its neighbor. It's 5 or more, so I raise the score by 1. So it'll be the same whole number, and then it'll be a 3. And then everything else behind it, behind. It sounded crazy when I said it. Everything else that's behind it is gone. Y'all ever write a whole bunch of papers or words, and then like stuff that you know how to spell kind of looks crazy to you? That's been my issue. I guess I've been working on this book and I'm just like cross-eyed and stuff. But yes, so that's how you round, okay? I see you, Kevin. Hey, I see you, Kevin. How you doing? Y'all make sure you go follow my guy, Kevin. Go ahead and tag yourself, dude. Tag yourself, dude. That is a NCLEX strategist extraordinaire. He's gonna help you break down these problems and give these questions what it's asking for, because it's not enough to just know the content. You need to know how to answer the question so that you get the answers right, okay? And that's how you get your points, and that's how you pass. So y'all are needing to follow this guy real bad, real bad. Alrighty. So your patient has a heparin drip running at 24 milliliters per hour. The heparin bag reads 12,500 units per 250 mLs. How many units per hour is the patient receiving? All right, what's the goal? Shar. Whoop whoop. That's what I'm talking about. Congratulations. What is our goal? What is this question asking for us to solve? Okay. Units is going to go on the top. That per is a line, right? Big per, hour. All right. So now we need our puzzle pieces. The things that are together, slash, put together, stay together. Things that's by themselves, stay by themselves, okay? So we've got 24 milliliters an hour. That's how fast it's going on the IV pump, okay? Then your medicine is 12,500 units per 250 ml, okay? So now that's all that it gives us, right? So we just got those two puzzle pieces. Now we just got to put it together. So if we're looking for units per hour, what do we start with first? I see you, Toy on YouTube. Mm-hmm. What do we start with first? You start with what the goal tells you to start with. Kevin, don't do that. Don't do that. Don't do that. We're going to follow the goal. Thank you, Fruit Snack Mama. Exactly. Take that question mark and put a doggone exclamation mark on there. There you go. All right. So we'll do 12,500 units per 250 ml. You keep everything together because remember, they're on one puzzle piece, okay? So now we've used that puzzle piece, it's gone. We've got milliliters at the bottom, so what do we need? Milliliters at the top, right? So 240 mLs per hour. Milliliters crosses out, and now you have the goal. Units on the top and hour on the bottom. So what we'll do is 12,500 times 24 divided by 250, which is going to be 1,200 units that they've received in this hour. Gotcha. Yeah, you got to remember to divide by your numerator. Love you too. Can you do pediatric burn questions like bolus and maintenance fluids? You got a specific one you want to send to me and I'll include it in this session or make a video? All right. So I'm going to do one more heparin question because this one was a little different than what you probably used to. Oh, that's too small. Can't see that. All right. Close your eyes. I need somebody to come up to, like, you know how they did back in the day and used to get into trouble with the chalkboards. You had to clean the chalkboards. I need a whiteboard eraser or whatever you want to call this. Am I on every day? No. Just when I get kind of the woo to do so. My scheduled lives, which will come on Sunday nights and Wednesday nights at 8 p.m. Central, they're on hold for right now. But I'm just dropping in hither and thither. So make sure you have the notifications on by following me here and I was about to say and all right. So this is a heparin weight-based problem, and it's got a bolus in here too. How many of you, when you see bolus, you get kind of anxious and nervous? It's okay. It's just us. We just talking. We just studying. Put a one in the chat. It gets you because of all of the steps. Okay. Well, it don't have to be all of those steps. Let's look how we're gonna do it. Let's look and see. Okay. Just hold on. Just hold on. Okay. The not sure how to send. If you have an example question, you can email it. Or you could send me a DM. Where is this little thing at? That's why it looks different because it's not up. That is my website. You can send it to me there. Also, if y'all are looking for like practice questions with like metric conversions, capsules, oral tabs, practice questions that you can print out and do, they're there. Yeah, in the cheat sheets. A, and all of it makes me nervous. Okay, that's okay, brown sugar. Want some of your brown sugar? All right, so listen. What a bolus is big word, big word. One time administration of a medicine or liquid or tube. Okay. Now that we've taken the intimidation factor away from that word, let's look at what this is. Heparin. Heparin is an anticoagulation drug, right? It's based off the weight of the patient, and we need to get it in the bloodstream, and we need to get it fast because what's it going to do? It's going to prevent your patient from clotting, right? It's going to change the bleed time. So, therefore, we have to give a bolus in order to get that medicine active and at a level that it's going to be working or therapeutic, okay? So, we will give a bolus first, and then we're going to maintain that level with a drip. Okie dokie. Let's read. The patient has an order for a heparin bolus of 4,000 units, followed by an IV drip of 14 units per kilogram per hour. The patient weighs 203 pounds. You have a heparin vial labeled 1,000 units per milliliter. Okay. What will you give your patient for the initial bolus? Then, what will you set your IV pump at for a continuous drip if your 1,000 milliliter bag is labeled 40,000 units of heparin? Okay, so first things first, we got to get that initial bolus. Initial means first, right? So anything that pertains to the bolus is the bolus. Anything that pertains to the drip is going to be for the drip. So our bolus order is 4,000 units, okay? And then it tells us that we have a vial, so that's a bottle with heparin in it. And it has a concentration of 1,000 units per milliliter. So I'm going to write bolus so we know that we are working on the bolus, okay? So we need to see how many milliliters is going to equal that 4,000 units that we're going to give, okay? So what's ordered is 4,000 units. What we have is 1,000 units per milliliter, and that's that. All the other information, because do you see in the order for the bolus, is it unit per kilogram per dose or anything else? No, this is going to be for the drip. Remember what I said, what is for the drip is going to be for the drip. What's for the bolus is for the bolus. Keep those pieces of information separate. Okay, so now since we're looking for milliliter, I'm going to take my puzzle piece with the milliliters in it and flip it. Boop, because that's what I want. I'm going to start with what I'm looking for, always. Even if I don't have it, I can start with a conversion if I have another puzzle piece with a unit that's relative to it, okay? So milliliter per 1,000 units. Now I'm just going to put my 4,000 units on the top. It's by itself, so I'll just put it over 1. And now what am I left with? Milliliters. So 4,000 divided by 1,000 is going to be 4 milliliters. So that's the bolus. That's it. That is the bolus. Okay, so we're halfway done with the problem. Now we need to set up the drip. Thank you for sharing the lives, and thank y'all for the likes too. Exactly, fruit snack mama. I can't talk. Fruit shot, shoot shot. She shot. Like, what? What are you saying? Alrighty. So, now the drip, okay? Whenever you see IV pump, know that it is going to be asking for milliliter per hour, okay? So our goal is milliliter per hour. So it says the drip is ordered. So this is the order. That's the prescription, right? So it'll be 14 units per kg per hour. And then we have, 203 pounds. And then our bag, because this is the drip, right? So you got to hook your IV bag up to the patient. Where do you hook your IV bag up to, patient? Okay, so it's 1,000 milliliters with 40,000 units of heparin floating around in it, okay? So if we're looking for milliliters on the top and hours on the bottom, we're going to start with those milliliters on the top, right? So I'll start with this puzzle piece. 1,000 mLs per 40,000 units. Then I'll put my units on the top. 14 units per kilogram per hour. Now I've got milliliter on the top and I've got hour on the bottom, but I got to get rid of these kgs. Our patient's weight is in pounds, so I'll put my conversion. And you see how I just put the conversion into the equation? I don't pick up the calculator until I'm done, and that's it. And then I don't even write down the numbers on the paper. I keep it inside the calculator. So if you're nervous about not having enough time to complete your questions, try using some of these tips that'll save off a bit of time too, okay? Alrighty. So then everything is now crossed out except for milliliters at the top and hours at the bottom, which is the goal. The goal is going to be your very, very, very best friend. Okay. So 1,000 times 14 times 203. And I'm going to hit divide. And I'm going to hit 40,000 divided by 2.2 equals 32.29. All right, let's practice what we did with rounding. If we want to round this to the nearest tenths place, what is our answer? Alicia, you can look at it on YouTube. It's on YouTube. You can look at the replay. It sure enough will be there. All right, I see a whole bunch of right answers. 32.2 if we rounded this to the nearest tenths place. It is fun. You're welcome. Yeah, all of my replays, or mostly all of the replays, because sometimes we have technical difficulties, are on the YouTube channel. I'll have like these problems broken down just by itself. So if you need to see just this type of problem, it's there. Y'all please take advantage of the resources. Let's see. I remember everyone needs a buddy to cross out except for what you're looking for. Yeah. Buddy, puzzle piece, whatever you need to do to understand it. However the goat can get the hay, it's up to you. It's easy. It's just dimensional analysis. And she's a good teacher. Thank you so much. I'm not a teacher. I'm a tutor. I don't have a master's in education. I have my BSN, and I'm not going to school right now. But my friend Kevin is. NCLEX extraordinaire strategist breaking down stuff. Y'all make sure y'all follow him, Nurse Kevin, the boot nurse. He goes live and he goes over nursing content and the questions and how to use your rationales, because that's very important when you're in school. It's not enough to know just the content. You got to know how to break it down and see what the question is asking you. Just like this one. What is the question asking you? No more, no less. Just give it what it wants, okay? But how do you know what order to put everything? Okay, so let's talk about it. So remember I was talking about puzzle pieces and goals and all that stuff? You might not have been here when I started talking about it, but I'm going to tell you again, okay? So listen, if you want to learn how to do this, I am coming out with a workbook really, really soon about how you do dimensional analysis with the puzzle piece method for almost all of your dosage calculations problems. There's a handful that require formulas, and they're different, like your BSA and your fluid volume maintenance, your tube feeding, and your percent solution. But for the most part, you can use dimensional analysis to do the rest of your dosage calculations, which is the majority that you'll see, and you use it the same way every single time. Okay, so puzzle pieces. Our goal is the picture on the puzzle box. Okay, because we did the bolus first, we no longer need the bolus information, so that's done. Okay, we needed to find how many milliliters per hour to set our IV pump so that they can get the drip. So it says an IV drip. So that's IV information. We need 14 units per kilogram per hour. And the patient weighs 203 pounds. And then it tells us that we had 1,000 milliliter bag with heparin in it. Okay, 40,000 units. How do I know what to place and where and how and when and all those questions, right? So the goal is a very important thing, because this is what you're looking for to be the answer, okay? It's going to tell you what it wants, okay? It tells us that we need the milliliters at the top and we need the hours to be at the bottom, okay? So if I need the milliliters to be at the top, I look for that puzzle piece over here. So these are my puzzle pieces, okay? I'm not going to try to draw a piece of puzzle because I can't draw. And y'all talk about me when I make diagrams, talking about my IV bag looks like a goalpost and such. And you hurt my feelings real bad, okay? Anywho, I'm not going to cry about it. And we're starting with milliliters, okay? So that is this piece right here. We have milliliters at the top, so the milliliters will stay at the top. What's together stays together. The goal is trying to get every unit to cross out except for the goal, okay? So in order to know what you need to cross out, you have to write your units of measure by your numbers. So if you're not doing that, stop. Don't do that, okay? Write your unit of measures by your numbers, okay? Because that's how you're going to know what to cross out, what cancels out, what comes next. So how do I know what comes next? You see this? That's a unit. That unit is not a part of the goal, so it's got to cancel out. In order for something to cancel out, it has to be in the numerator and the denominator. So I have 14 units right here. I'm going to put those on the top along with my kg per hour, because we can't break a puzzle piece. You can't cut a puzzle piece. You don't break a puzzle piece. In real life, you just reposition it, right? So we're going to put our puzzle piece in place so that the units cross out. So boom, those are gone. So now you have kilogram and hour at the bottom. Hour can stay. It doesn't need to be canceled out, because guess what? It's part of the goal. It is on the bottom. So it's part of the goal and it's in its place that it needs to be. So boom, it's cool. It's done. Okay. The thing that we need to cross out right here is kilograms. And because our patient's weight is in pounds, we need a conversion. So kilograms has to go at the top, and I know that 1 kilogram is 2.2 pounds. 2.2 pounds. So you see the kilograms crosses out. Now I can put my pounds at the top because they've got to go too, because they're not a part of the goal. And I put my pound, my 203 pounds over one to show you that it's single. It's by itself. It does not equal to anything. 203 pounds does not equal a day. So if something is by itself and a problem, leave it by itself. If it's relative, where it says per or in or to infuse in, indicating that it has a relation to something else, then they go together and they stay together real bad, okay? And they go on one puzzle piece. They are one, okay? And that's how you do it. You just go from unit to unit on the bottom and compare it to the goal. The goal is going to tell you where the units need to go. Once you have said units in said position and everything else is canceled out, your math will math. Hey, turn up. Let me see what I'm doing. Your name is Blessed RN on YouTube. It sure is. It's on all social media platforms. Facebook, Instagram is a.blessed.rn. And I have all of my links and stuff in my bio. Sure do. How do you know what order to put the little groups? I think I went over that. I need this. You need it in your life, Nisi. Yes, I'm just passing through to tell you to listen to this woman, Bianca. Oh my gosh, I'm so proud of you. And read through the problem. Breathe, exactly. Read through the problem. GTT, you round to the whole number. Yes, Nancy. They normally want you to round a GTT to the whole number because you cannot divide a drop. I have tried to understand DA, but I keep struggling. Have you tried it with the puzzle pieces? I dare you to. I triple dog dare you to. How do you round an answer like 0.25 to the nearest 10th or 100? So to the 100, it's already rounded to because there are no numbers after that. That 5 is in the hundreds place. If you rounded it to the 10th, 0.25 to the 10th, it would be, you start at the 10th, you go one decimal place to the right. Because that number is 5 or more, you raise the score by 1. So it'll be 0.3. Do you have one with the heparin adjustment chart? I don't. But all that is just changing the rate. Like if it's going at 14 units per kilogram per hour and it tells you to increase it by 2 units per kilogram per hour, you just add 2 to the 14 and recalculate the rate. I think like when you see charts and all and like, you know, those type of deals like with the APTT or the anti-10A or whatever, and it tells you what to do, you just look at the lab value. You see, do you hold it? Do you increase it? Or do you keep it the same? It doesn't have to be complicated. This problem gave me a headache. It's okay. We'll work on it. Safe dose questions and BSA. I'm gonna do a BSA, then I gotta go get my boo boo. Am I gonna do another question? Yes, I'm gonna do another one. Oh my God. Can you do more lives like this? I can't stay, but I need it. Pause. I will be back in live in full effect, scheduled on December 29th. So right now I'm just kind of hopping in and out, doing little sessions, little short sessions. Usually I do like an hour, hour and a half, and you know, we kind of get in this thing, we get it heavy, okay? And then also, if you do need private tutoring, I am available for tutoring. So just reach out to me, let me know what you need me to do. Do you times the top, then times the bottom and divide? Yes, yes you do. Thank you for sharing the live, boy, mom, Tish. Shared it 3 times. You meant that. I just wanted to do it. Okay. Do you only do dosage or more? Nope. Dosage is my baby. Dosage calculations is my baby. Is you is or is you ain't my baby. Alrighty. But there are other people who you can consult, like Nexus Nursing, Nurse Sarah, Nurse Kevin, who was on here earlier, Professor TK, the chemist, if you're doing chemistry. What am I looking for? Oh, that. All right, so that's BSA right there, okay? BSA is one of them that you really can't do with dimensional analysis except for the converting part. And I just uploaded like a short on YouTube. Yeah. and showed you how to do it both ways with the US conversions or the metrics conversions, because the metric one is going to be that 3600. So you see it's going to be the height times the weight. So the height has to be in kgs, the weight has to be the height has to be in centimeters, the weight has to be in kgs, and you divide it by 3600, and then you take the square root of that. If you use the US system of measure, the height has to be in inches and the weight has to be in pounds, and then you divide it by 3131. So, which one do y'all want to do? You want to do metric or do you want to do US? You can email it to me. Or you go on my website, you can email it to me, you can send it to me in my DM. Yeah, BSA is body surface area. So this is like a more precise way that they use with like elderly or pediatric patients, so that they are more accurately dosed. We know we have to be careful with the babies and with the old folks, because their metabolisms are different. You know, little babies are like fast. The old folks are like slow. So they have to be dosed very carefully. Okay, you want to do the first one? You just want to sit up here and do all of these god doggone conversions. That's what it is. Y'all trying to wear me out. But all right, let's do it. All right, so somebody give me a height and a weight. What about when they add a medication? How do we calculate like adding 4 milligrams of a medication? Evident. I'm trying to figure out what you're talking about. Can you give me a little bit more detail so I can answer it accurately? You said that's the one that you used at your school? Okay. I'm just fussing. Like, I don't like doing this. I like doing this. Once you get it, it's fun. I enjoy doing this. Like, I enjoy it. I like it. All right, so the first thing I see is 5 feet 6 inches, 287 pounds. All right, so let's do it. So patient's weight is 287 pounds. Patient's height is 5 feet. Where to go? 6 inches. Okay, and we're gonna do the metric version or formula. Okay, so BSA is meters squared. So if you see meters, so that's the little small m with the little 2 floating above it. That's your unit of measure for a metric. For a BSA problem. Okay. All right. So we're gonna take the square root of the weight in kgs times the height in centimeters divided by 3600. All right. What do we use most often? Fruit snack moment, either one, because they're both going to be the same thing. All right. What about, okay, that's when we use my school. So we have the height and the weight, and it also gives the medication. You'll send, okay, just see, yeah, send to my DM. You know what to do. You know what to do. All right, so we got to do some converting first before we put it into our problem, right? So let's convert the weight to kgs. So if I'm looking for kgs, I know that 1 kg is 2.2 pounds times 287 pounds over 1. Pounds crosses out. 287 divided by 2.2. It's going to be 130.5 kgs. Okay, so that is your kilograms. So now we have to convert the height. So we have to do 2 conversions for the height because we need centimeters. There is no direct foot and inches to centimeter conversion. So we have to convert all of the height to inches, and then we can do centimeters, okay? So we're going from inches to centimeters. So we have to convert these 5 feet first, right? So we know that we are looking for inches. So it'll be 12 inches equals 1 foot times 5 feet. So that's going to be 60 inches, right? And then we've got another 6 inches to add to it. So plus 6 inches is going to be 66 inches. So now I can convert my inches to centimeters, okay? So 2.54 centimeters is 1 inch. I'll put my 66 inches on the top so that they'll cross out. And then we'll do 66 times 2.54. And I got 167.64, okay? Centimeters. All right, so now we've got our metric conversions. The puzzle pieces gave you life. I love it. So now that we've got our conversions, we can put them into the formula. So we know that meters squared equals the square root of kg. So 130.5 times 167.67. I mean, sorry, 0.64 centimeters divided by 3,600, and we take the square root. 130.5 times 167.64 divided by 3,600 equals, and then the square root. So meters square is going to be 2.465, and so we'll do 2.47 because they usually round it to the hundreds place. So we have okay. Y'all good? You okay? We still living? We good? We good? Makes sense? So you see this one, you do have to use dimensional to find your values to go into the formula, but it is a formula that you have to remember. Oh, y'all know how I feel about formulas. Formulas. Wow, that was a lot, but it makes sense. Yeah. 2.54 centimeters is how many centimeters are in 1 inch. So that was our centimeter to inch conversion. God dog it. Drop my clip. Woo. I'm sweating. You're welcome. Y'all, it is, I don't know. It's like almost 70 degrees in Alabama. It's really hot. Oh my gosh. Nurse C says to do it this way. So, yes, you must know your conversions. You have to know your conversions. Your conversions will be the saving grace of dosage calculations for you. Is it true in nursing school you have 100%? Yeah, for some schools. Some require 80, some require 85, some require 90, 95, or 100. It just depends on what school you're going to. Yep. All right, I'm gonna cut this off on the two of you. Do 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 do.